Good afternoon, everyone, and good morning to you, Israel. As you're on the east coast of the USA, so it's still morning for you.
Yep.
Hi, everyone. It's Performance Tuesday today, and to round it off, we've got Israel, who's going to start with, I suppose, the basics and work through everything, which will be really good with CICS Performance and Tuning 101. So, Israel, you're an accomplished presenter. So I don't really need to tell you. Nick's going to keep an eye on the chat because everyone's on mute. And if we do get some questions, Nick will interrupt you mid-sentence and disturb your pitch to ask a question.
Yeah.
Sorry,
Perfect.
you're going to wait for a logical pause. Sorry.
Nah, he can interrupt me at any time, right? So anyway, good afternoon for you guys in the UK. Good morning for anyone in the US. And gosh, it must be middle of the night for other people. My name is Israel Gross. I'm with Rocket Software, and today I'm going to do this introduction to performance and tuning, right? So let me just say, if you're expecting an advanced presentation on exactly what areas to tune, then this is not the place for you. This is more of an introduction as to why you would actually tune your systems, right? We have a unique opportunity on the mainframe. In fact, we're expected to run at the lowest possible cost, of course, because everybody thinks we're so expensive, and we need the absolute best response time. So we measure things like response time in hundreds of milliseconds, not in seconds like the rest of the computing environment, so to speak. So I'm going to do this introduction to tuning, reasons to tune, talk a little bit about application versus system tuning, right? Some things about the tuning methodology, right? So how do you go about deciding what you're going to do? And hopefully I'll clarify that for you as well. Now, of course, I'm going to go through some of the CICS bits, right? Anatomy of response time. We'll talk a little bit about CPU time. And then we're going to get into the data collection and reporting facilities that are available to you. And again, I'm going to point out some CICS transactions you can run and take a look at to see what data you're actually collecting. And then we'll talk about getting started, things like monitoring, DFH0 stat to take a look at statistics or end of day statistics, right? And then some examples of resources to tune, right? Now, this is really product independent, although I do support CICS Performance Analyzer for IBM. There are other products that I work with on a tuning basis, and it doesn't really matter what product you're actually running because, at the end of the data is the same. It's only a matter of how you implement tuning changes. So the first question is why would you tune, right? So maybe you're getting poor response times. You want to take a look at applications versus the overall system. If the system is bad, then most of the applications will be running badly. Sometimes the system is fine and it's individual applications that are bad. And then you could have other problems like poor response times with network and DASD. And although you can't really tune them from the CICS perspective, you have to sometimes tune other things to make up for problems with other areas, right? You may be in a situation of increased workloads. Maybe you're doing consolidations. I know here in the US, we're consolidating companies all the time, and therefore you have to merge workloads, and then one tends to use more of a resource than another one, and sometimes you got to tune for that, right? You're going to get increased volumes. Maybe you're trying to postpone upgrades or reduce costs. You could do it for a learning experience, but it's kind of rare because you got to spend some time on that, right? So when do people actually do tuning? We tend to find that tuning is usually only done when problems or issues occur, which is kind of sad because by that point in time, you're under the gun to get something done quickly. But why not tune regularly? Well, turns out we tend to have a lack of resources, right? Staff reductions, the number of people managing mainframe systems today are quite a bit fewer than they were in the past. I remember when I started, I was in an environment where I had 20 systems programmers to manage 8 production regions, 8 acceptance regions, and 8 test regions. Those days are long gone, right? Well, we wrote a lot of our own code ourselves. Some other reasons, you might have lack of knowledge, right? It's hard to get up to speed. It's hard to find experts that know what they're doing in the different areas that are involved in tuning, right? You might have a lack of interest, right? From the application side, they're so busy making application changes, they don't have time to actually pay attention and see what it is they're actually doing. You might have some dependence on outside parties. Maybe you're running software from another company and you can't really do much, or maybe you can do some stuff, but not enough. And some people have the attitude, well, if it's not broken, don't fix it. Third-party packages, or the other big one is you can't tell what you're going to get at the end, right? So what is the return on investment that you're going to get at the end, right? So rules before you start, right? So here we go. If you're going to do tuning, tuning is a top-down activity. You start with the biggest thing and you work your way down, right? You make major changes first, one change at a time, right? Some people try and tune and change 15 things at the same time. And sometimes it's positive and sometimes it's negative. But the sad part is you don't know which thing worked out for you. So you really have to make them one, maybe two changes at a time, right? Some changes require iteration. So just as an example, if you're doing LSR pool tuning, right? You may get better the first time, but you didn't get quite what you wanted. And so you have to iterate over it and try and get it done. Yeah. Now, again, changes should be done gradually and monitored, i.e. you shouldn't schedule a change for every 2 days, right? Because again, it takes some time to figure out how well it's going. Tuning may not always be effective. You might be doing all the right things, right? But sometimes there are areas that you didn't take into an account, or you didn't realize were going on behind the scenes, and you make a change and actually things get worse, right? That's okay. You just have to back it out, right? Don't tune for the sake of tuning. You should be doing it with a purpose in mind, and then have a fallback position. So this is the methodology that I've seen over the years that people tend to use, right? Observe, measure, analyze, react, verify, and implement. So let's go through that. So observe. You have to really understand your environment from startup to shutdown, right? You want to know what your startup procedures look like, what the workloads are in the different regions you're working with, right? And set realistic objectives. You can't just say, well, I'm going to reduce the CPU cost by 50%. I'm going to improve the end-to-end response time by 50%. It doesn't work that way, right? You have to kind of have a goal in mind and set realistic values for that goal, right? Now, you want to develop a baseline. So you want to know how your system is running before you start, because otherwise there's no way to figure out whether you've made it better or worse, right? So things like CPU utilization overall and CICS, if you can do it, number of tasks per day, per hour, what's the average? What are your peak processing times? How do your response times look? Then you have to measure, right? Identify different areas to tune, right? So an example of this is, I just had a customer the other day. I was looking through their system. I was running some CICS PA reports because that's what I use to collect the data. And I happened to notice they were getting an excessive amount of IOs for temporary storage, just as an example. So I went ahead and took a look, and I saw they have no recoverable temp storage, and temp storage is above the bar. So maybe, I don't know, 20 years ago, they had a problem with storage and temp storage being in corn, so they used auxiliary temp storage, even though it's not recoverable. So my next tuning effort for them is to take that temporary storage and move it to main core and see if that will, number one, improve the performance of the application and then response time, but it's going to reduce IO, and IO is the most expensive thing you can get in your system. So I know it's going to be positive. I just don't know how much. And so I'm going to measure it, right? Determine my baseline and pick the tools that I want to run. In my case, it's going to be CICS PA, and then I'm going to measure before and after. So after I make that change, I'm going to analyze and see what I got, right? Because one of the biggest things about tuning is you're going to invest time in it. And if you invest time in it, you have to go back to people and show them that it was a positive or a negative effect, right? Because otherwise, why are you spending time doing it? Then you're going to react. You're going to make the appropriate changes. Maybe you did this in a test or a quality environment. Now you're going to try it in production, right? So you did it in development. You got some benefit. You couldn't measure it as much because it's development. There's not a lot of activity there. Maybe you went to QA. There's more activity, but not quite. Maybe you have a way to test your system and drive it, but you're probably not going to put it into production until you're sure that it isn't going to break anything. So again, you're going to react, and then you're going to ensure that you have a back out or a fallback position, right? Because you may need to back it out. Something you may not have considered may cause you to have to back it out. But if you don't back it out, you're going to verify the results from the change. And then if you're happy with the results from the change, you're going to institute it and implement it into production, right? And then you're going to go back and observe how it works in production. Now, notice there's a comment here about LSR pool tuning and other tuning efforts that you do. Sometimes you make that best guess, right? What is it with LSR tuning? So if I were tuning LSR, I expect look-aside hit ratio on the data CIs to be about 80%, on the index to be about 95% or higher, right? So maybe I'm going to make some changes and I'm going to get closer, but I'm not going to quite achieve my goal. But that doesn't mean I'm not going to implement it. I'm going to go ahead and implement that change. But then what I'm going to do is I'm going to iterate. I'm going to try again, right? And so I'm going to continually tune it until I'm satisfied that that's the best I'm going to get out of it. And sometimes there's that point of no return. That is to say, the effort involved in making the change, scheduling it, getting it in there is not worth the benefit you're going to get at the end. So this is a flow chart for us programmers in the world, right? That love to see everything under flow charts. It's the same thing we've been talking about before, but establishing a baseline, monitoring the systems, determining whether you met the objective or not. And if you didn't, you might need to tweak it a little bit and try again. So knowing your CICS or application is not enough from the corporate perspective. Every system is different, right? No two CICS systems are the same. Even when you have, cloned AORs, they tend to have some different things that run. Maybe that's not a good example because they might be exactly the same. And if they are, then usually a change in one will have the same positive effect in another. But generally, you'll still have some TORs, you'll have some FORs. And so the items that you can actually tune are going to be different across different systems. So what are the performance opportunities? Well, when you're looking at things to tune, you're looking at response time problems, processor overloaded. It's usually CPU and response time are the number one items that you're trying to improve. And again, you might have to deal with provisions for increased workloads. You might have some availability and reliability problems you want to look at. So that's not necessarily going to save you money, but maybe it's going to save you aggravation down the road, right? Maybe you have a lack of certain types of CICS resources and you have to look to add. And maybe you want to set a capacity planning baseline, right? And realization of new technologies, that's always a good one, right? Maybe you weren't using Java before and now you're going to start using Java and you want to see what it is to run a Liberty JVM in CICS and what resources it is going to take. It's going to use some storage above the bar, all those kinds of things when you put in something new. So when we talk response times, right, the system response is dealing with the allocation of resources, the processor speed, and then the underlying design of application code, right? When all else fails, I'll tell you, when I've done tuning and the number of years I've done tuning, I don't want to admit because then I have to tell you how old I am, but I find that for every system change I make to improve the performance of the overall system, I find that a single application change will usually double the improvement, right? So sometimes just looking at the underlying application and tweaking it slightly will save you more money than changing something in the overall system. Then there are other areas like network response, right? Transmissions through the network. Are you compressing the data streams? Or DASD response, caching and buffering to reduce or eliminate physical IOs, as I mentioned with LSR. I just had a company go from spinning disks to solid state. What a difference. performance, right? So there's always some improvement. If you can't improve those areas because they're outside your world, right? Because we're in the world of CICS, then you just have to deal with them and try and improve other areas. Now, increased workloads can cause failures in otherwise stable environments, and those are always opportunities to tune. Now, when you're looking at response times, you have to understand the type of transactions you actually have in your system. I kind of categorize them under three different things. The first one is non-conversational. You're in, you're out, you're done. It's like a web service, or you're using ZOS Connect or some other web-based transaction that comes into CICS, does something, comes back out, and you're done. That's a whole business transaction, right? The opposite side of that is conversational, right? It's like some of the IBM transactions, CEMT being an example of that, right? And then you have the pseudo conversational business transactions that we've had for many years, right? You have individual logical units of work. And as you go through 3270 screens or you drive applications under the covers, you actually have to drive a couple of different logical units of work to get one business transaction done, right? So when you're considering response times, you're going to see we can only consider them at the individual transaction or task basis. So that takes me to what is a CICS task in a program, right? Now, probably you all know what this is, but I just want to point out, because this is the level at which we tune, that when you start by typing in a TRAN ID, you get a screen back, you enter in some data, you hit enter, you get a screen back. These are the individual tasks. So when we actually do some tuning, we have to consider what's running in our system at the task level, not at the business transaction level. Sometimes you can drill down to the program level, but sometimes that can be quite a bit more difficult than you really want to do. So this is just giving you an idea of what a task is. And then of course, CICS is multitasking, giving response to each, giving CPU to each transaction in this task switching type environment. Of course, if you're running with open TCBs like L8s and L9s, you can get true parallel processing. But basically we run one thing at a time. If we have multiple TCBs, we can run multiple things at a time, but we're still constrained by the number of CPUs we have. And so the operating system is still going to do task switching, right? So I want to remind you of a CICS program as well. A CICS program is nothing other than a COBOL program, batch COBOL for that matter, where you have a sprinkling of exec CICS commands, which take you out of the application realm and into the system realm, right? So, you know, you could see an example here. I'm doing terminal control, DFH-ETC. Maybe I'm doing a little bit of file control, EIFC. Maybe there's a wait associated with that. And then here's a temp storage request. So the point is you're running COBOL. You're generally not interrupted during the COBOL unless you actually are a runaway task and you get purged. Really, the only time that you have the opportunity to task switch or wait is when you issue these exec CICS commands and the system decides to suspend you, which gives an opportunity for somebody else to run. So when you're looking at the overall response time of a transaction, because this is generally one of the areas you're going to spend time tuning, you have to consider all the individual pieces. When somebody types a TRAN ID and hits enter at a terminal, right? What happens? Well, somebody else actually attaches you into the system. And that's true, by the way, if you come in from the web, right? It's either CSOL or terminal control says, oh, somebody wants to run a piece of work. And the first thing that you experience is this first dispatch delay. That's you waiting for your chance to run. You don't have much in terms of control blocks within the system, and you can't really run at this point till you get this first dispatch, right? And then once you're actually dispatched, what's going to actually happen to you is you get a chance to get some CPU, and possibly you're going to issue a command that's going to get you suspended, and then you're going to end up waiting. And then the next thing that happens is even when you're ready to run, you might be in a position where you have this dispatch wait, which you're waiting for your turn again. So you could have that first dispatch delay. You can get additional dispatch delays depending on how often you're suspended, right? And the rest of the time is usually CPU time, but there could be some other MVS delays that go on behind the scenes. So When looking at a response time, the response time obviously consists of the time you're suspended, right? You're waiting for something, IO, for example, and then the dispatch time. But interestingly enough, dispatch time itself can be broken up into two different pieces as well, right? Dispatch time could include the CPU time, the time that you're actually running, and then other wait time, which is you think you're running. According to CICS, you're dispatched, but for some reason, CICS itself is not getting CPU, and therefore under the covers, you're not getting CPU, right? And so you can actually look at the dispatch time versus the CPU time, and you could determine how often you get CPU when CICS as a region is dispatched. And what we expect to see is a CPU to dispatch ratio of 80% or higher for a production region, and it probably should be even higher than that. So, and you can see that, by the way, in statistics. So there's a whole slew of different types of weights. Generally, most weight types today in CICS deal with IO, right? Because we have to wait for the data to be retrieved. But there are other types. There's terminal weights, but temp storage and transient data are all IO weights. File or RLS weights, journaling weights, they're all IOs. Inbound and outbound socket weights are not necessarily IO. And so you could see there are various different reasons why you could issue a command in CICS and end up waiting. So this is one of the rules about response time and how well you run within the system, right? This is response time, and it shows you a graph response time and transaction load. And one of the things you'll see is no matter what system it is, I guarantee you this, I would bet everything I have on this is that you could apply a transaction load that at some point in time turns up toward this infinite number, right? This is usually known as the knee of the curve, right? Effectively, to get good response time, you just have to make sure you're below the knee of the curve. Maybe that's right over here, right? Or maybe that's right where the blue line says it is, right? So effectively, for a given CICS system, if you want to keep that response time low enough so it's acceptable, you have to keep the workload or the transaction workload below a certain amount, right? You can't let it run up to infinity. Now, the sad part is it depends on the system where the knee of the curve is. And it's very hard to tell because this tends to change. It depends on the transaction mix in the system. So the best thing we can say is the lower the transaction workload, the better response time, right? So you have to make sure the system is tuned so that you don't overdo the transaction workload. So let's talk about tuning finally, right? There's lots of instrumentation data and measurement tools available to you. Here's a list of names, and I apologize if I missed any here. You know, Omegamon is one of the Rocket products I support as well, Performance Analyzer. But there's a whole slew of other things, right? And again, you can use any of these tools to take a look at the measurement data that's returned. So what does CICS provide you for monitoring? It's something called CMF. Now, in reality, CMF is just SMF records, type 110, SMF type 110, 110 type 1s or 110 type 2s, right? 110 type 1s is performance data, type 2 is statistics data. What's the difference? Performance data, you tend to get at least a record per transaction. Statistics data is based on the interval, and it'll give you overall statistics within the system. So when you look at CMF, there's the ability to collect up to 4 classes of data: exception, identity, performance, and transaction. Talk a little bit more about them later. They can produce a significant volume of data. So just be careful, right? You just don't want to turn the whole darn thing on. It could kill you. CICS compresses the data by default. You could include or exclude fields based on the monitoring control table that you set, an MCT. So it's really up to you if you're getting too much data. And then you could process the data using various different tools. So let's talk about it. I tend to collect exception class data. Why? Because it'll cut a record every time there's an exception. You're hoping not to get too many of these, so why not turn it on, right? So I tend to collect exception class. Identity class is fairly new. It provides enhanced audit information. It can capture identity propagation data for from clients across different systems, like if you're getting web transactions into CICS and you're looking at the identity data. I tend not to collect this. Performance class, I tend to collect this. This is 1 record per transaction. It'll give you the details, CPU time, response time, all the nice things you might want to see. And then there's transaction resource class. If I wanted to tune an individual resource class like file or temp storage, I might collect this data for a short period of time. But again, this would tend to increase the amount of data that you physically collect. So how do you process the data? Well, IBM provides a free sample program called DFH$mols that can be used to process the SMF data once it's offloaded, right? It'll allow you to sort and print the data. You can select or exclude data based on Apple ID, user ID, and Tran ID. It's fairly simplistic, but if you're a small shop, it does the job, right? MCT is key to determining how much data is physically collected again. So let's talk about how you see what's turned on. Now, obviously there are SIT parameters, but if you want to see what's running in your system, you can use the CEMN transaction. CEMN is the monitoring control facility transaction. And by the way, I included the documentation pages for this. So you could see I have monitoring class in general turned on, and then I identify which one of the 4 classes I have turned on. I have exception, performance, and resource. I have identity turned off. Now, when it comes to the resource class, you can actually further limit how many records are cut, right? When you're using, for example, DPL resources or file resources or TSQ resources. You notice we have compression turned on, and then there's some additional, there's some additional stuff for converse status or sync point status to deal with long running transactions, whether you want to collect the data. And by the way, the notes are right in here, so you can go back and read them, but I just hit PF1 on the actual screens. Then, if you go to the second page, frequency deals with how often to cut a record when you're running long-running conversational transactions, right? Otherwise, they would never cut any data, right? So you can actually cut no data or choose how often to cut data for a particular transaction. I actually cut them more often in a production environment, right? It depends on what they're doing, but this is, again, going to increase the volume of records that get written, okay? Now, again, you could read through what these things mean, but that's how you could verify whether this stuff is turned on. Okay. So, any questions so far? Because I've just rifled through a bunch of different things. Any questions?
No one's been brave enough to actually type anything yet, Ezreal. So I guess it's all very
probably because I haven't come up for a breath of air, right? So here we go. So I'll keep going then. So that is monitoring, right? CMF, it's SMF 110 type 1 and type 2 records, type 1 records so far. CICS statistics are the SMF 110 type 2 records. However, you don't have to go to SMF to see the data because there's other ways to see it. And I should have included a way to see whether this is turned on and what the interval was, and I don't think I did. But if you do a CEMT space I space statistics, or STA for short, it'll show you whether statistics is turned on, the collection, and how frequently you collect the records. Now, I'm more or less inclined today to collect the record on a 15-minute basis, because that'll give me 4 records per hour. In a 24-hour period, it'll give me 100 records, which is a joke in today's world, right? In the old days, maybe IBM used to have the interval at 3 hours, and then they reduced it to 1 hour, but I tend to like more records because then I can look at intervals at a much closer period, right? But anyway, statistics domain collects the data, it's written to SMF, and there's certain counters that can be reset. You can look at the interval recording with the stat record in the SIT, right? Which again, you could see with CEMTI stat, and records can be processed with DFH stat or DFH 0 stat, which I'll talk about. And then again, you can also process it with Tivoli decision support or CICS PA. So interval statistics, right? This is just interval related, and this is what I was talking about before. You have to turn it on in the SIT, and then you have to decide how often you're going to collect the data. And generally, I would recommend an hour or shorter. right? You also get end of day stats. You get that generally at midnight if you're running 24/7, or when you shut your regions down, you'll get end of day statistics. Then there's some other statistics. If you write programs, you can request statistics, right? You could do exec CICS, perform statistics record, right? Or record now. Again, you have to be careful because sometimes when you record your own statistics, it may reset some values and mess up your end of day stats. So you have to do some research if you're going to actually build a program that's going to collect statistics dynamically, right? There are also some resets you can set for request statistics reset. So if you want to, you can actually reset them yourself. I guess there's some value to doing that if you really want to. And then there's the unsolicited statistics, right? Statistics that get cut because suddenly you're allocating or deallocating files, or resources are deleted when you do a discard, or when you're auto installing, right? And so you get some unsolicited statistics as well. So how do you quickly look at statistics? This is one of the easiest things to do, right? There is an RDO group called DFH$stat, right? And you know you have it in your environment. I don't want to flip out of the presentation, but if you go into your CICS region, right, and you look at a transaction in your system called stat, first of all, if you have the transaction, and if it's pointing to a DFH program, then chances are the stat transaction will run DFH0stat. Right? If you have it, you can type that in. I would do it in a development environment. We'll show you what it does, right? There is a COBOL sample provided in source and load format. And so you really don't have to do much. You have to make sure you have access to the program, obviously, in your load library. But other than that, most customers just install the group and suddenly they can actually look at statistics during the day. Now, again, you could also use end of day stats if you prefer to look at a day's worth of statistics. When you run stat, it'll actually give you values from the last statistics collection. And you get to choose what you turn on and off. Now, spool must be set to yes in the sit because we're going to see where it spools it to. So here it is. I typed in stat in my CICS region, and you get this page first. This is one of my CICS regions. I guess at the time it was running TS53. It told me the Apple ID and sys ID, the class, and it says statistics recording is on. The interval in this region was 1 hour, right? And so you notice I can look at it over here. And then what we're going to do next is hit PF4 for report selection. Well, when you hit PF4 for report selection, notice it gives you a bunch of things you can get data on, and it's preset to certain values, right? So certain values are preset in here. Notice system status. He says, I'm going to produce a report. Storage manager, yes. Storage subpools, yes. Transaction manager, yes. Transactions themselves, no. So you can turn these on with yeses or nos, and you can see it gives you transaction manager, temp storage, files, LSR pools, which are great. You can get a page index. You can get information on library definitions, programs, log streams, journals, right? When you change any of these things, right, from yes to no, you must hit PF10. A lot of people don't realize that, but you have to hit PF10 to save the changes you've made. Once you do that, you hit PF3 to return to the page before, which will take you back here. And then you must hit PF5 right over there to print it. Now, once you've done that, all that's really going to happen is it's going to add something to the startup of CICS, right? So here's my CICS region. The region name here was CICS TS53. What I'm showing you is a page after I've actually done the question mark after it, right? So I've actually put a question mark next to the page already, next to the job itself, and I'm looking at the output. So you could see EYU log, you could see message user, right? And then you'll see this S0002, right? And you'll see it has a record count of 1,798. And that's where it dynamically wrote my statistics. So I can actually select it or view it. And then what I'm going to see is the reports I asked for in stat. right? So you could run this multiple times. It doesn't seem to be much overhead at all. So I've actually done it in production to get better data, and it'll show you some of the setup values within your system. So you could see some system status values. I cold started today, right? VTAM was open, thank goodness. Storage protection is active. Rent programs is set to protect. And again, this unfortunately is a page that you'll have to scroll to the right with PF11 unless you have your screen size set to 133 lines. I can see things like activity key point frequency, log defer interval, and so on. So I can actually take a look at the system status. And of course, I've asked for other reports as well. So here's a different report. This is the dispatcher report. And you could see my current ICV time, which we'll talk a little bit about later on, my ICVR, my ICV TSD, priority aging, and then some statistics. So you could see concurrent subtask values 1. That's my COTCB. I actually have one. You can see peak number of CICS dispatcher tasks is 33. Current number of TCBs attached is 13. The current number in use is 10. So if I wanted to try and get an idea of whether I'm hitting, the maximum number of TCBs I have specified, I can look at statistics, right? Now, again, generally you might be looking at this at the end of the day, but if you have a peak period and you want to take a look, you can run the stat transaction and you can get some information about statistics. So here is another page of my dispatcher TCB statistics. You can see the dispatcher start time, the address space accumulated CPU, and then you can see my individual TCBs, right? So you'll see I have 32 weights on my LA TCBs, which is okay, but I only have one in this system and it's currently attached. Now, this just happens to be from a different picture than before, I believe. And you can also see the QR TCB. You can see the amount of operating system weights, the total TCB dispatch time, and sadly, I can't shift to the right? So maybe I will try and run one of these a little later on, but if you hit PF11 and you shift to the right, it'll show you the total TCB dispatch time, and it'll show you the CPU time. And then all the way to the right, it'll show you that QR TCB to dispatch ratio. So if you remember a bunch of pages ago, I said it should be 80% or greater. So just by running the stat transaction and shifting over to the right, you'll see that you should be at greater than 80%. Now, there could still be a problem with that, right? What would be the problem? Well, if you're over 80% and you're 110%, right, then your QR TCB is overloaded. You might have to consider tuning the system or perhaps splitting the workload out. So that's just some of the things that you can do with the tuning information over here. So statistics, a way to run it dynamically, it's kind of nice, right? So that's something we can take a look at later on. So the next question is what resources should we go about tuning, right? Well, you notice CICS can sometimes be considered ceaseless in consuming storage, right? Storage was always a big problem. It's less so today, right? IBM has been moving more and more stuff above the bar. And as stuff moves above the bar, it leaves us more room below the bar or above the line to run applications. So CICS regions today can run a heck of a lot more workload than they could 10 years ago, right? And so the reason for having, thousands of regions might be less so today than they were in the past. Now, over time, they're going to move more and more stuff above the bar. So storage doesn't seem to be as big of a problem as it was in the past. If it is for you, then this is an area to tune. Now, keep in mind, you may not have storage constraints above the line and below the bar, but you might have it below the line, right? And so you might have to consider moving applications to run in 31-bit storage, right? Or you might have to tune for below the line storage, right? Because we're still constrained to 16 meg below there, right? So there are different things you could consider, like moving certain modules into LPA, and there are things behind the scenes for storage as well. So how much real storage versus virtual, and how much paging you're doing, right? So there are some areas to tune within virtual storage. right? There are other things as well, multi-engine exploitation. Maybe you have a lot of CPUs and most of your CICS regions run with a QRTCB and you're not using any of the open TCBs, right? So in that particular case, it might pay to take a look at an application, make it thread safe, take advantage of an open TCB, right? So by understanding a little bit more about the CICS dispatching mechanism and how CICS subtasks things, you might consider things to improve the performance. A good example for in this case would be, for example, maybe you're doing file control, and in development it's all local file control, so it can be thread safe. But suddenly you go out to quality or you go into production and you're running with file owning regions, right? And the connection from your AORs to the FORs are across memory. And maybe you find there's some advantage with the number of CPUs you have to convert that connection to an IPIC connection that will allow you to suddenly run the file control requests on an alternate TCB, right? So there's lots of things to consider if you want to take advantage of multi-engine exploitation. What about buffering techniques? Anything you can do to reduce IO is a good thing, trust me, right? So for example, temporary storage. If you don't need auxiliary temp storage, don't use it, right? Because there's always a threat that there'll be physical IO behind the scenes, okay? So you might want to consider reducing that. Transient data, again, is always, well, it's not always IO if it's not recoverable, but nonetheless, that might cause some IO. Logging is always IO. VSEM LSR, if you tune it properly, you can get look-aside hit ratios on data and index buffers, and therefore, perhaps you could reduce the IO dramatically. I had one customer, I reduced their IO by 40%, right? It was just some LSR tuning. Now, it took me 6 iterations to do it, but I got it done, yeah? And then VSEM RLS, you remove the ability to tune it within CICS, but you're hoping that somebody in the RLS world will tune it properly, and you'll get reduced CPU costs within CICS and possibly better performance. There are also network considerations, things like data stream compression, sometimes application design. Nobody bothers with MDTs and 3270 anymore. Those are a thing of the past, but web considerations are certainly a big deal as well. Maybe you're sending more data than you really have to, right? And sending that data to the network will affect the end-to-end response time, right? So what about serialization? That's where we tend to see bottlenecks, right? Where you can only get one transaction running at a time, right? I have one customer that can only run 2 transactions in a CICS region, and that CICS region is set to 1 gig, right? Because each transaction uses over 500 meg of virtual storage. I know this crazy world we live in, right? It's a batch application they run online. So obviously to reduce their bottleneck, I need to be able to run more than 2. Right? So I have to take care of their storage requirements, right? So I go back to the storage within the application. And if I design it properly, then suddenly I can get it up to 3 and 4, right? So you have to look where the bottlenecks live, right? CICS is really single threaded, right? Behind the scenes, certain resources are single threaded. And in those particular situations, you want to try and see what you can do to improve that single threading. Now, obviously, you can NQ and DQ around resources. You might have to if you have an application that's thread safe, but it has a bit of shared storage access. So you have an NQ, DQ, a little bit of single threading. The more you can reduce of single threading, the better off you are. Or perhaps, you can mark that application thread safe. You can always use T-class as an inhibitor, right? So just as a reminder, when you're making a change, don't tune for the sake of tuning, right? It can be counterproductive. Major constraints first, one change at a time. Do large changes gradually, right? In other words, don't make a change across the entire system and 100 production regions all at the same time. Try it in a couple, see how it works. Because remember, every system is different. And again, look at the systems and check any CICS thresholds that may need to be increased because of the problem that you're having, right? Application design, as I mentioned earlier, is one of the best areas to tune. And make sure you have a goal for what you're doing. So when you're making a change before and after, one of the best things to look at is CICS statistics. CICS has statistics in various different areas, right? Transaction manager, T-class storage manager, file control, temp storage, and so on. And so you can always look at the statistics before and after a change. So let's talk about some areas, right? So this is one of the areas that, I mentioned, but I don't know if I'm really happy about it. Max task, right? So when you're trying to figure out the max task for a particular CICS region, you could use that formula as a possible starting point, right? You take the transactions per second times 1.5 and the number of long running times 1.25 and the number of conversational transactions, just add them up and then add 25 for system transactions. And listen, you can use this formula quite well, but what is max task really there for? Max task is really there to control the amount of storage you use in a CICS system. If you set max task to 2000, what's really going to happen to you? Chances are your environment isn't going to run more than the average number of transactions it runs at the same time. So I have customers that set max task to 300, and then the next thing you know, I see on a daily basis, the average transactions per second they run is only 150. So what the heck are they setting it to 300 for? And could the system actually take 300? Well, then suddenly some problem occurs in the CICS system, right? I don't know, there's some bottleneck or some problem, and CICS transactions start to back up. So they get suspended. So the CICS allows more and more into the system up until it hits 300, right? The question is will you hit max task before you run out of storage? If you hit max task before you run out of storage, then chances are your max task value is set properly. If you run out of storage, if you run out of storage and you're not at max task, you're short on storage, then your max task value is too high. Effectively, max task should be set to the average number of transactions you tend to run in your system today, plus a little bit for load, for increase, and then you should track it. So in a system that runs 150 transactions per second, I would set it to 180, right? And then what I would do is look at it every so often to see if I ever hit that point. Because what I would rather do is if I have a problem, set my system to max task so I'm identified through my monitor that have a problem with my CICS region. And that's how I would set max task, right? Now, again, keep in mind that when you set max task, the system has to have enough storage above the line and below the line, and theoretically above the bar, although we're not using much of that yet, right? To support the number of applications that you want to run. And so you have to pay attention to how to set storage, right? EDSA lim, right? The storage above the line, right? How do you set that value? Well, it depends. For example, are you running with transaction isolation on or off? If transaction isolation is on, you need 1 meg per user. So if you set your max task to 200, you have to make sure your EDSA lim is at least at, 100 for the system, another 200 for the transactions that are running, right? Now, again, we tend to run with 800, which is the default of IBM today, so it's not as big of a deal, but nonetheless, you might need to pay attention to that. You might also have to use a T-class to control high volume transactions. So here's an example of what you can look at in terms of statistics. You can see how many times you hit max tasks, the current active tasks, the peak active tasks, and the total active user transactions, right? And then transactions delayed for max task 0. So in this environment, I don't really have to increase max task, and I have it set to 100, as you can see right there. So what about T-class? When do you use T-classing, right? T-classing is used to control any resource hogs, right? You could also use it to single thread transactions. I have some customers that say, I don't want more of one of these transactions running at a given time. And so what I'm going to do is put it in a T-class, set the max active to 1, right? And this way I never run more than 1 at a time, right? Now, again, you can also use it to control how many of a transaction you run. And you also have to pay attention to the other options you have for T-class to ensure you don't end up with MRO sympathy sickness. And I'm going to show you that in just a second, right? But again, how do you measure the effectiveness of T-class? Well, first you have to figure out why you did it, right? So the only way to measure it is to know what you did. So if you're looking for a single resource running at a time, then It's easy to measure. Did it work out for you? Could you run more than one at a time? And then you have to make sure that maybe there's a storage hog that runs below the line and you don't want to run more than 5 of these at a time, right? So you have to make sure that 5 is all you can run. Maybe you can get away with 6. Maybe 5 is too much. Got to lower it to 4, right? And then have any tasks waited? If so, were the resources available in the end? And could you have added to the T-class value? So when you look at T-class, you'll notice that you can set the max active. The max active says how many you can run at a given time. And again, this is from an older release of CICS, but it's still true today. There's a max active value, right, which you set to 1 or 5, and that's how many you can run. But then there's this purge threshold. And notice I have purge threshold set to 0. In real life, I never set purge threshold to 0, because what that says is I will allow an unlimited number of people waiting to get into this class, right? And there's always a risk. You never really want to do this, right? No matter what value you pick for purge threshold, you should have a value in there. And notice purge threshold doesn't support 0, and it doesn't necessarily work the way you think it does. Purge threshold, when you set it to 1, will allow one person to wait. It will not allow even one person to wait. It'll purge the first guy, right? So the number is when you hit that number, we're going to purge the guy. So if you set purge threshold to 1, you're not saying I want one person to wait. You're saying I want no people to wait, right? If you want one person to be able to wait or 10 people to wait, set the purge threshold to 2, or in the case of 10, you have to set it to 11. So the 11th guy will purge. Now, again, it's better to get an ABN than to wait forever, right? You don't want to be in a situation where you're hanging people up forever, right? And so you have to keep in mind that the way CICS works when a transaction is attached, it's the transaction manager that will hold you up for max task or T-class, which means you have at least the transaction manager transaction control block and a couple of others. So setting purge threshold to no and getting a flood of transactions, thousands of them, could cause your region to go short on storage and bring the entire environment down, right? So setting purge threshold to no is a little bit dangerous. What about task priority and priority aging, which is set in the SIT? Well, first of all, what I find today is most customers do not set task level priorities. I mean, they have the system ones set, like CEMT is the highest priority, but how do priorities actually work, and do they have any value today? Well, you know, and again, this might be just my opinion, so let me just warn you here, right? I tend to find most of the time you don't need to spend a lot of time figuring out priorities, because in reality, if transactions aren't getting sub-second response time, somebody is moaning, right, in your environment that something is going wrong. So does it really matter if you have a transaction that will run 10 milliseconds before another transaction? Probably not. Plus, setting priorities are very, very difficult, right? Because you set a value from 1 to 255, and you actually set it on a terminal, you set it on the transaction, and you set it on the user ID, right? So theoretically, you could set 255, 255, and 255. The problem is the maximum is 255 to begin with. So you have to be very careful, otherwise everybody gets the highest priority, because you set 100 here and 100 there and 100 there, and geez, that's 300, it's over 255 and everything is set. So if transaction priorities work for you, go ahead. But generally, I don't invest a lot of time in transaction priorities. Now, the same thing is true for priority aging. Right? When IBM first came out with this, they set it to 32K, which is a crazy number, because that meant you had to wait on the dispatcher queue 32 seconds before your overall priority would be increased by 1, which is usually a very long period of time, right? And so priority aging, if you're going to use it, has to be set to a small number, something around 100 or less. Now, what does priority aging actually do? If you have a priority-oriented system, it gives you the ability to up priorities of lower priority tasks based on the time they spent in the system. Well, the argument could be made, if you have priorities in your system, then you don't want to give lower priority tasks too much priority, right? That's the whole point of it. But you want to avoid what we call as starvation, right? Which means because there's always some higher priority task coming into the system, it'll never get a chance to run. So it's a good thing to have something. So I'd have priority age set to some value, but I wouldn't, again, play too much with it because it's very hard to affect change. And by the way, the minute you get that number right, it'll be wrong tomorrow because it really depends on the workload of the system. So I think that it's one of those parameters that IBM didn't think entirely through because you have to have a setting based on the workload within your environment itself. So again, our recommendation in general, only use transaction priority for system transactions. So you can always get in when the system is really busy. If used, base priority on transaction in person, not terminal. We don't have too many terminals today anyway. If used, do not use wide ranges of priorities. Don't do 50, 51, and 52. It's a waste of time, right? Do, 50, 100, 150, and 200 and set 4 settings and no more than that, because otherwise it's impossible to manage. Right? So again, if you're going to consider using priorities, right, you have to ask a couple of questions. Why am I using transaction priorities? The system has to be running at a very high CPU utilization for tasks to not get dispatched. And like I mentioned earlier, so, okay, now suddenly a transaction runs 100 milliseconds faster than another transaction. Is that really something you really wanted? Is it going to make a difference if you're expecting sub-second response time? I doubt it, right? So again, should you spend the CPU time it takes to manage this entire system, transaction priorities and priority aging, although it is actually very small, or would your time be spent better somewhere else? Here's a couple of free gimmies. Region exit interval, or ICV time, one of the most misunderstood parameters. ICV time, what does it actually do? It gives CICS the ability to sleep when it has no work to do. It's set in the sit, right? And it can be looked at when you look at dispatcher statistics. And effectively, when you look at what IBM sets as the default, I think the default is 1,000. So CICS will not sleep for more than 1,000 milliseconds, which is 1 second at a time, by default, right? Now you'll notice that ICV, I'm sorry, we're already showing you ICVR. So ICV time, what should you set the interval control value? Well, I tend to set it pretty high, around 10,000, right? But now let's talk about something, right? Because theoretically, if CICS has work to do, it will have no value whatsoever because CICS will wake up the minute there is work to do. So let's talk about runaway task. It's another one. If you happen to have problems with runaway tasks, what we're showing you here is we recommend setting the runaway task time on the individual transactions and setting the system value to the lowest possible value, which is 500. Why? Because systems are getting faster. The CPU you're running today is a lot faster than the CPU of 5 years ago, right? 500 milliseconds, right, in a 100 MIP machine or a 1,000 MIP machine or whatever it is quite a lot of time to run through COBOL, right? Even complex COBOL. So what we'd prefer to do is set the system value down to 500 milliseconds and then run individual transactions that have ICVR or need bigger runaway values on the transaction definition itself. This way, if you get a true runaway task, you're not wasting all that CPU. Because I have customers that run the system level runaway task at, I don't know, like you see 10,000. And the next thing you know, the system can actually let a task run away for 10 seconds. And next thing, the entire system is backing up as well. So it can create other problems. There's also the ability to set things like D timeouts. I always code a deadlock timeout because I think there's what it really is a suspend timeout. If a task is suspended for more than 30 seconds, I think that's ridiculous unless you actually expect it to be suspended for more than 30 seconds. You should set a D timeout value that makes sense in your environment so that you don't have these tasks that get suspended and then other tasks that could back up behind it, right? And so again, specify D timeout and S purge for all transactions, right, that do not have any updates to resources such as things like inquiry or menu or browse. And again, having a D timeout for a transaction is not a bad thing to set up in advance. So here's a little bit of dispatcher statistics. You could see the total number of transactions in my system, current max task limit, peak number of transactions. And then down at the bottom of the dispatcher statistics, you could see things like current number of tasks, peak number of tasks. There's my ICV time, interval control value. Again, I make that larger. ICV TSD should always be set to 0. The default is 0 today. So again, in summary, and I just made my time, there are many areas in which CICS can be tuned. To get the best results, you got to do it more than once every 5 years, right? You just have to have some time set away every month or whatnot to do tuning. Always start at the top and work your way down. Set reasonable objectives and make sure you show before and after. Publish your results. It doesn't sound like something you might need to do because you made the system run better. But at the end of the day, what you'll find is by publishing those results, you might be given more time to do more tuning because the results hopefully will be effective. So any questions?
Not as yet. It's a blank canvas, shall we say.
No, I wanted to jump in the last 5-10 minutes, but I knew you were running close to the time, Ezra, so
I timed things pretty well, didn't I?
But yeah, priority aging, I wouldn't touch that with a barge pole.
Yes, I know.
Burned by that in the past.
Yeah. It can burn you, right? Because what ends up happening is if you set the number too low, then suddenly you're really first in, first out, and you get no priorities left, right? So it really depends on how you want to run your system.
Yeah, I've seen like long running tasks just swapping in and out of the dispatcher and not letting anybody else have a go. And
yep.
With all of that stuff, I think if you've got a very simple monoline application, it can work for some things where you want real fast response time for some of it. But as soon as you've got any kind of generic application region with surfacing a whole range of customers, there's just too much work to keep it up to date. Almost impossible. Every time we have a performance problem, we always end up looking at it still as part of the whole gamut of things that you can tune. But I think the best thing was that what was it, RFE years ago, where they changed CEMT, didn't they? Because it was like real low and the system got hung. That was the best thing I ever did.
Yeah, there's been some problems over the years, some of which they've certainly fixed. But I will tell you, it's very rare that I go about tuning a system where I don't find at least 2 or 3 instant carrots where I could save CPU time, improve the performance of an application, right? And so, again, maybe in the future, I'll put on like an actual tuning presentation where, we'll go about and tune a couple of items within the system and show some examples, right? Obviously, that was more introductory level, but keep in mind, there are just some real gimmies within a CICS system that people forget about, because when was the last time anyone tunes a system, right? And that's the problem. We're short on resources. There's no people to do it, but the mainframe is a strange place. We expect instant response time, right? Sub-second. And at the same time, we got to reduce the CPU because we actually pay for CPU like you don't in other systems, right?
Well, I mean, ICV, for example, you mentioned that, but if you've got 17,000 test systems sitting there doing nothing that some people might have, it might be a good idea to have a longer value there.
Absolutely.
CPU.
Absolutely. The funny part is in the latest releases of CICS, I tried it in a very boring system with no work to do. And I still find that CICS rarely can sleep more than 7 seconds at a time, right? I haven't been able to drive that number higher. It might be something in my system that's installed, You know, some request wakes up kicks, right? So, you know, setting it to 30,000 is nice, but I never get kicks to sleep for 30 seconds. I will say that people going, why would you want kicks to sleep longer when he has no work to do? Well, in middle of the night, when you keep those kicks regions up and running and nobody's doing any work, amazingly enough, the batch throughput improves, right? So I had one customer that saw improved performance of batch because we raised ICV time. Crazy things, right? So you never know what value it'll have as long as it's not negative, right? And you're not using CPU for nothing. Kicks wakes up, says I have nothing to do, goes back to sleep, is costing you CPU. So depending on the number of regions and how often that happens, it could cost you real money. Yeah.
Yeah, brilliant. Thank you so much, Ezra.
Well, thank you. If there are no other questions, thank you everybody for attending, and hopefully you enjoyed it. You too, Nick. You learned something?
Oh, there are a lot of numbers, man.
Okay,
gotcha. Perfect.
Okay, folks, that's our last session today. We've got a fullish agenda tomorrow, certainly starting early, 9 a.m. UK time. And I think we've got Mark Cocker talking about Kafka.
Yeah, dangerous precedent. MQ and Kicks talking together. It's
Yeah, I figured you guys did it, you know, at 4 a.m. my time, so I wouldn't be there to ask questions. I got you. No problem.
Well, Kafka is an interesting sort of, almost feels like a bit of a double-edged sword to me, with all the stuff that goes off host, and certainly the MQ messaging will be interesting. But thanks for your time, Ezra, again. And folks, if you can fill the feedback form in, you'll win a prize. And we'll see you tomorrow at 9. Thank
you, guys.
Cheers, Ezra.
Take care.
Cheers.
Bye-bye.
Bye.